Hello engineers, welcome back. In the previous video, we got the theoretical understanding of Kruskal algorithm for forming a minimum spanning tree, right? In this video, we're going to code it in C++ and see how that looks like. Okay, so let's get started. So let's go to VS Code. So I've created a new file called Kruskal algorithm and I've created the base template so we can get started. So what do we need? We need the disjoint set from our previous video. So I will directly take this class from here and we'll use it here. Okay, so this is what we need to perform our find and union operations for the disjoint set, right? So how does algorithm go like? Just a quick recap from our previous video. First, we need to sort the edges in the ascending order. Once we sort the edges in the ascending order, we process each of the edges using our find and union methods to create a parent array that is reflecting all these edges, right? And the only thing that we need to do is while we are processing, we need to check whether we need to include this in our minimum spanning tree or not. And what is the condition to include it? We need to check whether it is forming a cycle or not. And what is the condition to check whether it is forming a cycle or not? We need to check if they have the same parent. If both source and destination nodes have the same parent, which means that if we include this edge, it will form a cycle. So we will not include this. Okay, so let's go step by step. First, let's create a data type that will hold this structure: source, destination, and weight. So let's create a class. Let's call it edge. And this will have three things. Let's call them U, V, and weight. So this is the source, this is the destination, and this is the weight. Okay, and we will take in a constructor and initialize all this. We will just initialize them as they are. And that's it. So this will be our custom data type, which will hold this pattern: source, destination, and weight. Okay, so let's use this here to build our vector of edges. So we will create an array of edges which is carrying this pattern. So vector of type edge, and let's call it edges. And now we can fill our edges. So let me quickly create this pattern for this graph and then we'll see you. Okay, so I have created the edges just like this graph here. So the first edge is between Sam and Tom, which is 0,1, and then the weight is 2. Okay, and then we have edge between Sam and Jerry, which is of the weight 7, and so on. So I've created all these edges here, and now we are ready to move forward. So what is the first step? The first step is to sort them in ascending order, right? So for that, we will use the C++ built-in sort function to sort them in ascending order. So we will pass in our vector and we will give it a range. So we will say start at the first edge and then go all the way up to the last edge. So this is the range. And now we need to give it the function using which it will sort. So for that, we will use this syntax. Okay, so this is the sorting function. So what is this doing? It is saying take this range edges.begin, edges.end, which is basically this whole thing. And then we are saying use the weights. Inside this, we have something called weights, right? Use the weights to perform the sorting. So if we are doing a.weight less than b.weight, which means that the lowest one will come first in the sort order. So we will have an ascending order sort with this. So sorting is done. Now we need to process each of these edges. For that, we will use a for loop. Now we need to process each of these edges. So what do we need? For this we will need a disjoint set. So let's create that. And what will be the size of this? It will be the size of the edges, number of edges. Okay, so that is done. So what we do? We pass in each edge into the disjoint set. And what does the disjoint set take? It will have two things, find and union. So we will pass into the union, and union will take two things, the source and the destination. So we will get the source from U, we will get the destination from V. Okay, so we are passing one edge at a time to perform the union. Okay, and now as we perform the union, as we go on processing this, we need to check for a minimum spanning tree condition. Okay, we need to know whether to include them in the minimum spanning tree or not. For that, let's first create a minimum spanning tree vector, which will also be of edge vector. So let's call it MST. And when do we add our edge to the minimum spanning tree? That is a question, right? So for that, we need to ask who are the parents. Like this here, we asked who is the parent of Ben, 3, who is the parent of Jerry, 3. And because they are the same parent, we decided not to include it in the minimum spanning tree. So the opposite condition is, if they don't have the same parents, then we will include them in the minimum spanning tree, right? So we will do that. So first, let's get the parents. ds.find edge.u. So we are asking who is the parent of U, and we will ask who is the parent of V. If they are the same, we will not include it. But if it is not same, we will include it. So if root U is not equal to root V, then we can add it to our minimum spanning tree, push back edge. And that's it. So we are processing every edge for union, and before processing we are checking if it is to be included in the minimum spanning tree or not. Finally, we can simply print the minimum spanning tree. So now we are printing the minimum spanning tree edges. So let's print it like this. First we will print the U, edge.u, followed by a comma, followed by edge.v, followed by another comma, followed by edge.weight, and then we will close the bracket. And that's it. So ideally what should happen? What should happen is we have 1, 2, 3, 6 edges, and as we discussed in our dry run yesterday, one of the edges should be removed. Okay, and the remaining ones should be part of the minimum spanning tree. Let's see. Okay, now we have our output. Now we have 1, 2, 3, 4, 5 edges out of 6, and which is the edge that got removed? The edge with the weight 6. And this was the edge, as we discussed yesterday. This was forming a cycle, right? So we have eliminated it yesterday in our dry run, and similarly our algorithm has also eliminated and given us the output in the ascending order. Okay, we have the remaining edges in our graph. So this is how Kruskal algorithm is implemented in C++. So quick recap, what did we do? First, we sorted them in ascending order using our inbuilt sort method. Okay, and then we started to process each of the edge and gave it to our union. Okay, and within union, what is happening? Within union, we are checking who is the parent. If the source and destination have different parents, then we perform union by size. Okay, and after that, before passing it to the union, if the parents of source and destination, if they are different, current parents, if they are different, then we will add them to our minimum spanning tree. Okay, this is another vector we have just used. And finally, we have printed our minimum spanning tree, and we found out that the cycle creating edge is not included here. Okay, So that is the implementation of Kruskal algorithm. And with this, I think this is the last video in the series of data structures and algorithms playlist. And I hope you really enjoyed it. I was very excited to create it, and I feel I have covered all the fundamentals. But if you need any video on any particular topic, definitely let me know. I will try to add them up in the future in the middle of the playlist somewhere. Okay. So thank you so much for watching, guys. You have been very helpful, very supportive. Thank you for all the support. Thank you for all the subscribers. Thank you to all the likes and comments. They are very motivating and encouraging for me to make more videos. Thank you so much for watching. I will see you in the next playlist. Cheers.